So this week and today we're going to look at differentiating the three types of SQL, so there's three types of SQL, calculating the result of given what's called non-joined SQL statements, and then proposing different types of SQL statements, again for non-joined use cases. The non-joined portion of this will make a lot more sense next week when we do joined SQL, but in the meantime, it's non-joined SQL statements. So a bit of a plan, so some context, what is SQL? We're going to jump in with one of the types of SQL, data definition language, then some questions, then some data manipulation language, then some questions, and then the end of the lecture, and you get to go free. So back to the question at the start then. This is the Ishango bone. Has anyone heard of that before? The Ishango bone. It's the oldest piece of recorded data, right? These notches are data of some kind. Do we know what they are? No. What happens if you apply context to data? Does anyone know? No? Well, without context, this is just raw data, right? It means nothing. If you apply context to the data, for example, like you said earlier, if this was tracking the number of people in a tribe, you then have what we refer to as information. It's not just data anymore, it's information as well. So this is the oldest recording of data, and data is tended to be, now this is a definition I found online, raw facts and figures that make no sense or do not have any meaning. Right? So that's data. Data doesn't have inherent meaning unless someone provides you the context of that data. If I started writing numbers on the whiteboard down here without providing you the context, they mean absolutely nothing. That's data. We then have databases. Database is an organized collection of structured data. Complicated way of saying an organized collection of data. So your filing cabinets at home, your notepads, they are all databases of some kind. And in this case, the data on this Ishango bone are the notches itself, and the database is the bone. It's holding the data. So that's a good way of thinking about it. I mentioned structured data. So this is probably what you're most used to. You know, tables of information, tables of data. Now this is what we're going to be doing most, well, it's what we're going to be using most when we talk about SQL, is structured data. So it's tabular, it contains properties, which are columns, and entities, which are rows. So hopefully you're all familiar with this from using either Excel or looking at data tables from your previous studies. But essentially what we're talking about here is structured data. We also have unstructured data, which we're going to cover later in the course, which are things like images, videos, sounds, etc. So those things that don't fit into a tabular structure, we're going to talk about later in the course, I think around week 10. Okay, so starting off then, what is SQL? SQL is a high-level programming language, and it's used to query, modify, and create what's called relational databases. Now they're called relational for a reason you'll find out next week, but databases are structured data, tabular data sets, and we can use SQL to query and modify them. There are three core components. I already mentioned two of them. Data definition language, which is the language used to create and modify the structure of the data. You have data manipulation language, which is the language used to insert, create, update, delete data from the database itself. And then you have data control language that we're not really going to touch on in this course, but it's relevant for you to know, is the language of which you apply permissions to users, allow users to access databases, create new users, create new roles, and the sort of more security aspects of a database system. In this course, we'll be using SQL-Lite syntax. So there are many types of SQL. In this course, we're going to use SQL-Lite. And anytime I use code, I'm going to use this font. I know for some people this font's slightly hard to read, but if you go online and look at the lecture slides, you can modify the font there. But I think this is also coherent with what Ken does as well, so at least there's some consistency. Okay, so, well, this is your first step of SQL, create database. These are two SQL commands. The first one tells you to create something, and the second one says a database. Now, technically, what I've done is made a mistake here, because it should be create database, and then the name of the database. So this allows you to create a database from scratch using SQL, and that's what it does. It creates an empty box. So if we go to the next slide, we can create a database called database orders, and there we go, we've got a database. It's empty, it contains nothing, but it is still a database. What else can we do? Well, we can create tables. So we can start to create this tabular structure, and we do this using the create table statement. So the way this is structured is you have create table, so you're creating type table, you give the table a name, in this case customer, and then you have open brackets, and you can provide a list of columns that you want in that table. So in this case I've provided an email and a date join column. They're different data types, we'll go through those in a second. And then what I've done is I've assigned what's called a primary key. Now every table in structured data has to have some sort of unique identifier for every row. So every row in your table needs to have some sort of unique identifier. Now you're probably familiar with unique identifiers. Your student number, for example, is the unique identifier to your row in the student record. Your email address is probably your most commonly used unique identifier. So in this case, I've set the unique identifier, what's known as a primary key, to email. So we're creating tables, or creating a table, with a given name, and then in the brackets, we have three lines, 2 of which are columns, 1 setting the unique identifier, and then they have some data types. So the data types we can use when primary keys. Data types we can use when creating these are things like char, varchar, text for textual, string type data. You've got your numerical data types, like int, real, boolean, timings, date time, and then there are tons of others that you can look up in your own time. But the main ones you use are the top 3. So it's worth pointing out here, the main difference between what you're probably used to in Python is the string data type. Here we have char and varchar. So in this case, char is followed by an x. Now that x is the length, the maximum length that this column can hold. So if I was to put a 5 in here, then the maximum length any value in that column can hold is 5. Same with varchar. So we can do varchar 5, and then whatever it is, maximum length of 5. The main difference between these two is that varchar is variable. So what that means is, if I were to put in lion, it only has to be 4 letters long. Whereas if I put lion into here, it's going to add a space afterwards, because char must be 5 characters long. It's not necessarily a maximum here, more of a necessity. It must be 5 characters, minimum and maximum, whereas the varchar can vary anything up to. Text is a much larger data type, so if you're storing like a description of a book, for example, or an abstract, then you probably use the text data type, and it's a much larger piece of information. As you move along, so from char to varchar to text, and as you make the sizes bigger, obviously you're taking up more memory, and therefore the performance will slow slightly depending on what servers you're using. Numerical data types, you've got integers, int, real numbers, so things like decimals, and then boolean, which allows 1 and 0, so true or false. Exactly the same as Python. We then have date and date time. The only difference is date doesn't contain a time, and date time contains a time as well. Perfect. So with that in mind then, where's the mouse gone? Let's have a go at labeling some data types. So I think you've got about 20 seconds here. Which type would you use to hold a price? It'll give you several options. So you've got int, text, varchar, char, or float. Which one would be most suitable to hold a price? Everyone's voted. Float. Brilliant. Yep, float. Why can't we use an int? Anyone? Yep.
Doesn't have any decimal places.
Good, doesn't have any decimal places, and 99p stores are quite famous, so 0.99, you won't be able to store that. Perfect. So, altering tables then. So we created a table called customer of 2 columns, email and date join. We can add columns to this table using the alter table statement. So this is your second statement we're going to look at today. Alter table, the table name, which in this case is customer, and then we're going to add, so that means we're going to create a new column, and we're going to call it custID with a type of int. So it's almost identical to how we created the table in the first place, right? We have create table, table name, bunch of columns. In this case, we have alter table, what table we're altering, add column, so you can either say add or add column, doesn't matter. Cust ID int. So in this case, it's going to add this cust ID to the table. You can see, nice little graphic there. It just adds it into column. What else can we do? Well, we can remove columns. Again, alter table customer. So again, you're altering the table. What table? Customer. This time we want to drop column date joined. So what that means is remove the column called date joined. Now you'll see here I've used drop column instead of just drop. They're both exactly the same. So if you were to instead write add column in the top line, it would still have the same effect. It's just shorthand and down to preference which one you want to use. We can rename columns. So let's say you want to suddenly decide that you want to change one of your column names. Let's wait for people to settle down. Hello? Bus just pull in. Yeah. So again, we have the alter table, customer. But this time, we're renaming the column, whatever column you want to rename, to whatever you want its new name to be. Okay, so similar syntax on all of them. All you've got to change really is the operator here. So add, drop, rename. You can add column if you want, you don't need to. It's up to you. There's one last thing you might want to do, which is retype column, which is, to be fair, probably something you should never do if you designed your system right. So what do I mean by retype? I mean change the type of a column. So ID originally was an integer. If you wanted to change that to double, you can't really do it in SQLite because you shouldn't really be doing it at all. Yeah, come in. But if you were to do it in Postgres, which is another type of SQL, alter column ID, type double. So again, similar format anyway. But really you want to avoid altering the type of a database at all costs because once you alter the type, data changes within the tables and that's probably something you don't want to manage. Final one. Drop table customer. What does that do? I've written it there. Removes the table, right? So drop, in this case, generally means remove. And when you drop table customer, even if it's got data in there, everything removes. It all goes. So be very, very careful whenever you type the word drop into a database system, because the chances are you're also dropping something you weren't too sure about. Okay? So just be very careful when you're doing the remove, doing the drop even. Okay, any questions on altering tables? No? We're all experts at this already. Lovely. In that case, here's some SQL. Can everyone see that at the back? The SQL, yeah? Can you read that, okay? Perfect. For some reason... Oh, okay, it is working. Oh, look at that. Brilliant. You guys have just joined. We're using Mentimeter for this. The joining instructions are at the top there. What I'll do is I'll leave this open for a couple of seconds, let people read the SQL, and for those of you who just joined us, join. Do you get to pick your own picture, or does it just randomize? Perfect, that seems like enough of you. Okay, so it's just one question on this slide. How many columns exist in the student table once I've executed all of this code? Hey, perfect. Okay, good. Most of you got the right answer. 5. So let's just run through this then. So our student table, first off, let's just shorthand this. So student. So how many do we start with once we've created the table? 4, good. So we have 1, 2, 3, 4. Line number 8, what's that do? Down the front here, what does line number 8 do? Adding another one, good. So we go 5. Line number 9 at the back. One more, yep, perfect. So we're now on 6. Line number 10 drops it, so we lose one. And line number 11 down the front. Doesn't change anything, right? It's just renaming something, so we don't need to do anything. I can't say anything. Line number 12. Adds 1, good. So we're back up to 6. And number 13. That's 1, brilliant. So we're back down to 5. That's not how you tally, is it? There you go, much better. Perfect. Okay, so we've got another one coming up. Is anyone slightly confused by any of that? Yeah, sorry.
Do you always count the primary key as a column?
So the primary key will always be a column. Yeah. So when it's defined here, you must define the column first, and then the primary key. There are multiple ways of defining the primary key, which you'll see when you go through the exercises. But generally, you define all your columns, then select one of them to be the primary key. So you can think of it like a subtype of column, in a way. It's still a column by its own right, but it also has special properties. Okay? Perfect. So next one then, I'll give you some time, 15 or so extra seconds, because it only gives you 20 seconds to answer. This time we're looking at tables. How many tables exist following this code? You can assume that the bits and ellipses are perfectly written code. Lovely, let's see how you did. 4, good. 4 tables. Not bad going. So, let's count the tables. So we have create table student, I'll give you that one for free, that's 1. Create table course, that's 2. Drop table student. What's that do? Drops on the table. Well, that's a bit, it still disappears. Create table student registration at the back. What's it do? Creates a table, good. Back to 2. Alter table course, rename column, lecture ID to teacher ID. What's that do? Nothing. Good stuff, yeah. Create table teacher, that adds 1. Create table course allocation. Alter table course, drop column, teacher ID. No. What is that doing? Drops a column, good, yeah, so it removes a column from that table. Perfect. So that, in a nutshell, is data definition language. Well done. You did it in 35 minutes. Is this another question? Oh, write a query this time to delete the course table from a given database. So you're given access to a database. They want you to write an SQL query that deletes or removes the course table. One person straight in there. The correct answer is drop table, oh sorry, it's really small here, drop table course. So we have a couple different answers here. How many of you got it right? How many of you got it wrong? About the same, okay. So drop table course, I mean, that's kind of right, yeah, just missed a semicolon. Not quite, you need to drop the table, yeah? Because if you drop, you got to tell it what you're dropping. Is it a database or is it a table? Alter database, I see where you're going with that, yeah? Alter table, alter database, but in this case you don't need to do that, so you just drop the table. But the answer is, for those of you who can't see it, because it is quite small, drop table, what was the table called? Course. and semicolon at the end. Now, SQL doesn't actually care about your capitalization. But what we tend to do is put all the SQL sort of terms in caps so that it distinguishes itself from the rest of your code. Another thing SQL doesn't care about is white space. So if I wanted to, for example, drop table course, I could also do that. Yeah? So drop table course, that will also still work. Okay, over to data manipulation language then. So we've created our table. We've created this customer table, the one you just created here. The first thing we might want to do is insert some data. So here we use insert into. So again, almost like the alter table, but this time we're inserting into the table name, which is customer, and then we provide it some values. Now the way you provide these values can vary, and we'll show you a couple examples of that. But generally what you do is you put them in brackets and you provide it like a list of the column, the column values. So in this case, we have an email of a@b.com and an ID of 1. So we pass it both like that. When you're passing sort of characters or varchars or date times, you'll generally use quotes to separate them out as text, and then the database will interpret that for you. When you're using numbers, whether that's floating points, reals, or integers, just put the number in there. You don't need the quotes. We can insert multiple rows. So insert into again, table, customer, values, set 1, set 2. Yeah, so you just separate them via a comma, and then you can insert 2 rows like that. Notice here how I've had a break line here. Again, SQL does not care about your white space, so you can do this perfectly fine. As long as you finish with a semicolon, SQL is quite happy. Yep. So generally people stick to single quotations, and that's only because when you're writing in Python, when you pass, let's say you're writing that top line in Python and you're passing it to a database, you'd already have quotes around it because it's a string. So using single quotes inside that makes it easier to differentiate. But you'll see that when you practically do it later on. You can specify columns, so you don't have to insert all the data at once. You can insert into customer which columns do you want to insert, and then which values do you want to insert into that column. So here we just inserted the value 8. Let's go back and forward there so you can see it. Just inserted the value 8 into that column. So you don't need to fill all the columns at once. It's recommended you do, but you don't need to. Any questions on inserting data? Yes? Yeah, so if we had email, values, and then an email address. Yeah. Mm-hmm. Oh, I see. So this, but without the 1. No, you need to specify the columns. So notice here we specified only the ID column. If you were to specify the email column, then yes, you could do that. But if you want to insert rows like that, it's sort of like an easy way of doing it, only if you're inserting the whole row at once. If you do want to only insert columns, you do have to specify. For example, if there were 3 columns, you could only insert 2 by putting ID, email. Same way of doing it. But we should see that later in an example, actually. So I'll point that out when it comes up. Any other questions? Yeah.
So if I want to insert the email in the column next to, like, in the row where I entered email,
Here.
how do I do that?
Good question. That's coming up next. Updating a row. So we can update data in the table by using the update command. So you say update what table you want to update, and then you set whatever column equal to something. So what I've done here, I've missed out a semicolon, sorry. Update the table customer and set the email equal to d@c.com. What's the problem with that? Yeah, changes all of them. So is there a question?
We don't mention, but how does it know which rows
Good question. At the moment, what's it doing? Yeah, it's doing all of them. Good. So this is where our good friend, the where clause comes in. So here we have where customer set email equals that, right? So you're updating the email address. You can then specify a where. So think of this like your if statement in Python, where the ID is 8. So if there were multiple rows of an ID of 8, all of them would update their email address. In this case, it's just the 1, but we'll see an example of that later when we do a big example. So the where clause allows you to do lots of different things. So for example, we could have said where email equals a@b.com, or you can do date time comparisons. You can do all sorts with the where clause. And I think we touch on that now? No, we'll touch on that after this. Okay. So you can compare any column to any type, as long as you provide it the right information. So whether it's a varchar, or an int, or a float, or a boolean, or a date time, you can compare, and you can do all your normal operators, greater than, less than, equal to, etc. Deleting data. Delete from customer. Yeah?
So if we have like ID with the four IDs with the 8,
Mm-hmm.
and there is only one row in the mail that is empty,
Yep.
and we have to update only that. So how can we do that?
So,
Because this all the rows with
Mhm.
ID 8 are updating this.
yeah, exactly. So, in that case, you do something. We'll touch on this later, but I'll also touch on it now just so it's less confusing. So the question was, if there were multiple rows, let's just add another row on here, with 8, and I want to update their email addresses, but only the email addresses where the email doesn't exist. Is that the question?
Yes.
Yeah, where the email doesn't exist. We put an and. You'll see this later on, but I'll do it now. Email is, I believe it's none, or no, it's wrong actually, that's Python. Null, thank you, I'm trying to mold now. Null. So that, what null means is empty, right? Yeah.
So apart from the primary key way to, go there and insert things, is there also a way to index the rows, like fourth row or fifth row?
There is, but that's highly discouraged, because when we get to scalability, you'll see that parts of the database can be stored in different places. So the way in which you access things is slightly different. But once you retrieve the data from the database, obviously you've got a list of it, so you can index it if you want. Okay? Yep.
Is this not similar to SQL where you write is not null or
Yeah, it's identical.
Yeah, but so you can't use it interchangeably.
Yeah, so I don't think SQLite has an is null, but that's the same as is null in TSQL. Perfect. Oh, yes.
In the previous slide, if you use the first query without specifying the where clause, will it update all the emails in the column?
Yeah, so that will update every email, irrelevant of whether it's there or not. Okay. So, delete from customer. Again, not helpful, right? Unless you want to delete everything from your database. Lack of a where clause, you can add a where clause. So instead of updating everything, here we've just deleted where the email is equal to d@c.com. So again, you're seeing that you can specify the rows by doing this. However, you'll never guarantee to only have one row, right? You might be updating multiple rows. Just make sure your primary keys are in good shape and you should be okay. Finally, retrieving data. Sorry, were there any questions on deleting? Kind of it's exactly the same as update, but a bit simpler. Yeah? So here is about retrieving the data for you to use in Python or whatever else. So we use the select command. You tell it which columns you want, and then you say from what table you want it from. So an example, select email from customer will retrieve you a list of emails. Yeah? All of the emails in this case. And you can add a where clause onto this as well. So here we're saying select email and ID from the customer table, but only where the ID is greater than, less than or equal to 2. So it's only going to retrieve those top 2 rows for me. Okay? Any questions on this? There's a special case for select where you can provide select star or select asterisk, and all that means is all of the columns. I want all of the columns. It's just a shorthand way of doing it, rather than writing out all the columns every time. So again, another example, where ID is greater than 2, we've retrieved all columns. The where clause, as we mentioned a second ago, can have multiple conditions. So, for example, we can select all from customer, again using a break line, where email is a@c.com, or the ID is greater than 1. So in this case, you can see that we've retrieved this one of the email address, and this one because the ID is greater than 1. Okay? Good. Other operators. So they're same as in Python mostly. And, or, not. You can use all of those. There's like, which allows you to use regular expressions or wildcards, for those of you that are familiar with that. Between, so that allows you to compare between two numbers or two dates. In lets you provide a list of values, and it says whether something is in this list of values. And there's a whole lot more. Okay, but those are the basic ones. Yes?
When you select,
Mhm.
we get a subtable from our main table. Can we then perform operations on that subtable?
Yes, you can. So you can, for example, perform updates using a select from somewhere else. But that's, we're going to cover that later in the course.
But is that a good coding practice?
Yes, because sometimes it's the only way of doing things. But it's something you have to be very careful about doing. But in some cases, it is the only way to do it. Okay, so this is just a large example for you now. So I've emptied the table, and what we're going to do is I'm just going to insert some data using 3 different methods. So I've inserted 2 full rows. I've then inserted this one with a no ID. I've then inserted just an email down at the bottom. So you can see we've got 2 email addresses here with no IDs, and 2 email addresses where the ID is 5. Any questions on those 3? Good. What's going to happen here? Update customer, so we're updating a customer table. I want to set ID equal to 3, but only where the email equals a@b.com. Which row is going to change its ID? The 3rd row, yeah, good. It's going to change the 3rd row to 3. Delete from customer where ID is null. So you can use this null, there we go. So that means where the ID is empty. So which row is going to go? Disappeared. The 4th row, good. Update customer, set ID equal to null, where email equals a@b.com. At the back over there, what's happening? Yeah, good. So the 3 is going to disappear. We can select email from customer, where the ID is equal to 5. What are we expecting to be returned? The first email, yeah? Nothing else, just the email. Or first 2, actually. Because they're both ID 5. Yeah, sorry, I misspoke. How about select email, comma, ID from customer, where ID is not null? First 2 again. But this time, we've also got our ID column. Any questions on this? No? Perfect. It's getting this a lot faster than last year. I don't know if I'm allowed to say that. Cool. So, we've now got a bit of a test for you. Don't worry, it's not marked. It's all anonymous. Here's some SQL code. We all have a bit of SQL code. So here we're creating a table, inserting some data, and selecting some data. How many columns will be returned from that final statement? 1, 2, or 3? Two, good. Who said 3? No, I'm joking, don't point the answer. So we've only got 2 columns in this table. Yeah. We've got 3 data items, or 3 rows, but 2 columns. Yeah. So maybe there was a terminology thing there. But 3 rows, 2 columns. The columns are determined by which columns are in the table, and in this case we use the asterisk, which means what? All the columns, good, which in this case is 2. Okay, another one for you. I think this is the same sort of question, just with more data. How many rows will be returned from the final select query? So how many rows this time, not columns? Two, good. So in this case, we're saying there's some white space here, so I'm just showing you different ways of applying the white space. Sometimes it makes it easier to read as well. So we're selecting every column from the inventory, which is this table, where the quantity is greater than 100. Right? So here we're inserting values, and quantity is the second value. We know that because it's the second column. So we have not this one, 1, 2, because null is not a number. Okay? Any questions on that? No? Good. Surprising that some of you said 5. So remember, the asterisk is all columns, not necessarily all rows. Yeah? The where is applied to columns and rows. Another one then. Same question, different code. Pretty sure the data might be the same, but how many rows this time are returned from the final select statement? So again, how many rows, not columns? Three, good. Now I can understand, I think, why some of you may have said 2, because between is quite ambiguous, yeah? So, if anything, it was a bit of a cruel question, really. So, less than or equal to, greater than or equal to 2, less than 5. So, you go greater than or equal to the first number, less than the second number. So, have you done range in Python yet? Yeah, so you start at 0, you go to 5, but you don't reach 5. Yeah, same principle. Okay. But I understand why you made that mistake. I don't think there was any other differences here. Again, we're still using the select asterisk because I'm lazy. Here we go, proposing some SQL. So we've got four SQL statements here. The first one, alter student update forename to George, where student ID is 5. Update student set forename to George, where student ID is 5. Update student alter forename equal to George. And alter student set forename to George. All of them have the where student ID is 5. But which one correctly sets the forename to George for the student with student ID of 5? Or stu ID of 5? We've got far more of you in here now than we did earlier. B, yeah, brilliant. So update student, set the forename equal to something where student ID is 5. Okay? Some of you chose A, alter. Again, alter is a DDL statement, so it's all about the definition language of the structure of the database, whereas update is a DML statement, which is manipulating the data underneath. One final one then. So here we have some delete statements. Which block of code will delete all students enrolled in the year 2012? Got this horrible between again, as well as less than or equal to's. Apparently this one doesn't have a time on it, so just go, I guess. And we'll stop when there's a reasonable number of you voted. B, good. I think there are multiple correct answers here. I think. I wrote this a week ago, so. Good stuff. Give me 10 more seconds. Okay, so the correct answer, the first two. So, oh, I lied to you earlier. Did anyone know the mistake I made? Sorry, yes.
How is A correct if it doesn't account for
Yeah, exactly. Yeah, I lied to you, didn't I? I made a mistake. Good catch. I caught myself out as well, apparently. So it turns out between does include the end date. So that's my fault. Either way, only 2% of you got it wrong, which is exciting. B is the more, well, it's the same thing, right? It's just less than or equal to signs. unlike me, make sure you read between before you use it. Otherwise, you'll fall into that mistake right there. Okay, so that's all the questions. One last thing I want to check with you, and I'll do this at the end of every session, but I want to make sure we hit our objectives. So our 3 objectives at the start were differentiating between 3 types of SQL, calculating the result of given SQL statements, and proposing suitable SQL statements for given use cases. How much more comfortable are you doing that now compared to earlier? This won't hurt my feelings. I'm a big boy, I can handle it. But it's just good to know where you're at, okay? In which case, if for whatever reason it was terrible, we can look at it again next week and go from there. What I will say is there are some optional, well I say optional, they're formative exercises on Moodle. If any of this is confusing, walk through them. They're quite self-explanatory if you just step through the goals. I've also provided all of the code in the lecture in like a readable format in a Jupyter notebook, so you can, I wrote as I speak, so you can see me step through each line of code and it produces the real database live for you. Brilliant, so that seems like most of you are quite happy. Optional practicals, you've used Jupyter Notebook now? Good, that's all you need for this, as well as SQLite 3. But you can do that using pip install SQLite 3. If anyone has any issues with that,